In this problem, we need to use row operations on an augmented matrix to solve the given system of linear equations. So this is a pretty chunky problem. No denying that. It's like expired milk after 2 weeks. So we're going to look at all of these one by one. These two are the biggest issues. So we're not going to look at those. What I do notice is on the fourth row, we're missing a y here. And then on the third row, we're given these two variables. So what I'm thinking is we take this third row and we solve for y. So we're going to say x plus 2, because we're going to add 2 from both sides, is equal to y, because we're going to add y to both sides. So this is going to give us an equation for y. Well, that doesn't solve for y, so how is that useful? Well, we don't have a y here, but we do have a y here and a y here. And if we have an equation for y, we can write this in terms of x, add the like terms, and then we will no longer have a y. Let's explain this a little bit. So for the first equation, we're going to rewrite this. We're going to have x minus 2 times our x plus 2 in parentheses, because that's what our y is, right? We're substituting. We're going to have a plus 3z plus w is equal to negative 2. Now continuing this, we're going to factor in the negative 2. So we're going to have negative 2x minus 4 plus 3z plus w is equal to negative 2. Well, if we do some math, we're going to add the x's together. That's going to give us a negative x. And then if we add 4 to both sides, we are going to continue and have a plus 3z plus w is equal to 2. Now, this is going to be our first equation. Now, we can continue and go look at the next one. I'm going to do this part in red. So we have x minus 3. We have our y, which is x plus 2. And then we're going to have a plus z minus w is equal to negative 7. Now we are going to add our like terms, and actually we're going to factor in first. So we're going to have x minus 3x minus 6 plus z minus w is equal to negative 7. We're going to add 6 to both sides. We are going to add our x's together. This is going to give us a negative 2x plus z minus w is equal to minus 1. This will be our second equation. And for our third equation, we're just going to look at the bottom one. We're actually just going to pull this over here. X plus z plus w is equal to 2. So these are our three equations. Pretty simple. We simplified it, and now it looks like the previous problem that we've done. So what's going to be our base case? Well, I'm going to use the second one. And you would say, why am I using the second one? Why not the first one? Well, if we use the second one, we can see that we can add these two together. So the middle and the bottom one, our base and the bottom one. If we add them together, the w cancels out. And if we do the same thing, because we have to have the base case, if we add the base case and this top case together, the w cancels out as well. So it's important to look what you want to cancel out and the simplest way to do it when you're doing these problems. I'm going to come over here and rewrite this. If we add the first two together, we're going to get a negative 3x plus 4z. We are going to have the w's cancel out. It's going to be 0 is equal to 1. Now, for the next part, we're adding the middle and the bottom one together. So we're going to get a negative x. We're going to get a plus 2z. And this is equal to 1. Now we have these two equations. From here, we could either solve for x or z. I am going to solve for the z. I'll just choose to solve for z. They both seem equally not very difficult or difficult, depending on how you look at it. But I'm just going to choose z. So we're going to multiply everything by a negative 2. And if we do this, the top is going to remain the same. The only thing that's changing is the bottom. We are going to have a 2x minus a 4z is equal to negative 2. So we can add these together. We are going to get a negative x. Our z's are going to cancel out, and this is equal to a negative 1. Well, the negatives can cancel out, so our x is equal to 1. We are going to look back at the problem. Just going to look back at all of our work. We're going to continue here. We're going to look back here. Always do this, by the way. Look back here. Look back here. And we have this equation that we could plug our x into and find z. So we are going to do just that. We are going to have a negative 3 times 1 plus 4z is equal to 1. If we add 3 to both sides to get rid of the 3 here, we're going to have a 4z is equal to 4. So our z is equal to 1. That's pretty good. We have our x and our z. Now what can we do? Well, we can look back at the actual initial equation that we were given here, because we have x, z, and w, and we can use this to solve for our w. I'm going to actually number these steps for clarity. This is step 1, and this was step 2, finding the z. Well, this was actually more step 2. So I'll write this as step 3, and this is step 2. And then our step 4 is going to be finding the w. We're plugging it back into this original equation. Our x is 1. We don't have a y. We know our z is 1 too. So 1 plus 1 plus w is equal to 2. These two added together are 2, plus w is equal to 2. If we subtract 2 from both sides, we're going to get a 0. So w is equal to 0. We found our w. And we don't need to do any hard equations, because if we look at this third part, we can see we have an x and a y as our unknown. We have our x, but we don't know the y. So we can just solve for our y. In fact, we have this equation right here, and we are going to use that equation. So if we plug our x in, we are going to have a 1 plus 2 is equal to y. So we're going to have a 3 is equal to y. When we write this in as our answer, our x is 1, our y is 3, our z is 1, and our w is 0. If we wanted to go even further and actually check this, we can plug this into one of the original equations. Plug it in for the first one. So x is 1 minus 2 times our y, 3, plus 3 times our z, which is 1, plus a 0, should be equal to negative 2, right? Well, if we combine some things, we have a 1 minus 6 plus 3. This should equal to negative 2 again. Well, if we add the positives together, that's going to be a 4. 4 minus 6 is equal to negative 2. So we have negative 2 is equal to negative 2. And that checks out. If we wanted to be really, really careful, we could plug them in and solve for each of these. I'm not going to do that, trust. But that will give us the answer to this problem.